In this module, we'll be talking about SQL versus NoSQL systems. Our main objective is to understand what a NoSQL DBMS is and what the differences between SQL and NoSQL systems are, and what the key takeaways for us as developers are, and how we should make the choice of choosing a particular database for the application that we're building. So NoSQL systems are systems that typically don't use the tabular format or the abstraction of having a table, columns put together in a schema, like that kind of abstraction that relational databases provide. Mostly NoSQL systems are one of two types. So they're either document stores where they are storing documents instead of rows. So two or more documents inside a collection or inside a table may have nothing to do with each other. This is very different to a relational model where multiple rows in the table all have the same schema and the same columns, and each column has the same type. However, in a database like MongoDB, you can have documents that are stored in a collection, which is the equivalent of rows in a table, and each of these documents might actually have different columns, and they might even have the same column names but with different types. The other kind of common NoSQL system is a key value store. And you can think of key value stores as tables that have just two columns, a key and a value. Key value stores are very useful for caching like applications, and Redis is one of the best examples of a key value NoSQL system. Most NoSQL systems sacrifice on support for transactions, ACID, and joins. So they also sometimes sacrifice on the kind of consistency that we expect in a relational database because of the lack of a schema. NoSQL systems in modern times have been motivated by two main factors. The first factor is the desire to simplify the DBMS design. And by simplifying DBMS design, I mean that these NoSQL systems try to reduce the number of features that a database can provide. For example, foreign key, constraint checking, or transaction support. And they do this so that it's easier to reason about things like performance, because the database does much lesser work when you're trying to read data or write data. A very good example of this kind of a system is MongoDB. The other main motivation behind NoSQL systems is the desire to be able to scale to vast amounts of data very, very easily. So if you're willing to sacrifice on certain features of our database, then NoSQL systems are able to provide a very easy way to scale to very, very large amounts of data. And by very, very large amounts of data, I'm talking about the scale of a few terabytes to a few petabytes. Some common NoSQL systems are MongoDB, Elasticsearch, Cassandra, Redis, and HBase. Most all NoSQL systems are extremely diverse, and there is no actual common standard of what a NoSQL database is or how a NoSQL database is structured. It's not really two categories of databases called NoSQL databases and SQL databases. It's rather SQL databases and other databases, which are all grouped together and called NoSQL databases. From a developer's point of view, the main difference between a NoSQL database and an SQL database is about how we think about our constraints. So as a developer, if we want the database to do our work, to do the work of checking our constraints and making sure that constraints in our data models are validated, then SQL is a good fit. However, as developers, if we don't want the database to model our constraints and we're willing to do the extra work to gain on features like scaling to hundreds of terabytes of data, then a NoSQL system is a good fit. So for example, NoSQL systems do not allow modeling of schema, constraint modeling, or support transactions. Most NoSQL systems, some NoSQL systems do support a subset of these features. So if we use a NoSQL database, that means that we must write code in our application to actually model these constraints. So for example, if we look at the applications that we were building, if we want to enforce that in an article, the user ID or the author ID of a particular article must actually exist in a user table, it is not possible to enforce this kind of a constraint in a NoSQL system. This kind of a constraint must be validated by us at the application. So that means that if somebody goes and modifies the database directly, there is no guarantee that the data models will have a certain amount of consistency. It is very important to remember that we should not try to take a NoSQL system to try to solve the problems that are already solved by SQL systems, and vice versa. Let's talk a little bit about document stores, which is a category of NoSQL databases. So MongoDB and Elasticsearch are the two most common examples of document stores. These databases store JSON like objects in a collection, and these objects or documents are analogous to rows. Both MongoDB and Elasticsearch try to support clustering out of the box, which means that if we want to store more data and we want to have the same performance, then we just have to add another machine to our cluster, and the database system will automatically replicate and shard the data between two instances of the database in the cluster. So we don't have to worry about how to shard our data, or we don't have to worry about how to do the replication, and this happens automatically. So if we have to choose between SQL and NoSQL systems, what are the factors that we should use to decide? Sometimes there are very clear-cut use cases for SQL and NoSQL systems. For example, if we want to support financial transactions that require ACID properties, then in such a situation, as a developer, one should blindly choose a mature SQL system which will support transactions in ACID, be the primary database. Another extreme example is if we need a very fast in-memory store, which is typically a use case for caching, and we want to store our data on RAM. We don't care about writing our data to disk, and we want read and write access to be extremely fast. This is a perfect use case for a NoSQL system like Redis. But most of the times the lines are blurry. It is not a clear-cut choice between SQL and NoSQL systems. Let's look at a few examples. Postgres is technically an SQL database and a relational database. However, Postgres can store unstructured data using the JSON column type. And in fact, Postgres's performance in reading and writing JSON data rivals or exceeds that of MongoDB in a few cases. In another case, there are extensions to the Postgres system that allow for horizontal scaling to petabyte scale data, and just by adding more machines to a cluster, very similar to NoSQL systems, and they do this by sacrificing on some SQL features. Similarly, Aerospike is a NoSQL database that actually supports ACID properties. A lot of things are continuously changing month on month, year on year in this environment, and so it's very hard to choose a database that is one size fits all that will work in all scenarios. So when we're in a situation like this, how do we make the right decisions? The first important thing to remember as a developer, especially if we are starting to build applications, is that almost any popular DBMS is good enough. If you're building a simple application, the difference is not going to be between choosing MongoDB or MySQL or Postgres. The difference is actually going to be in building the application till it reaches a scale of data or data usage that actually brings out the differences between these different database management systems. If you have a database size which is less than 1 terabyte and you are a typical web application, then there will almost be no difference between you using MongoDB, MySQL or PostgreSQL. When you're choosing a DBMS, the most important thing is to choose a DBMS with a huge and a vibrant community, preferably one with several tutorials and Stack Overflow questions and answers, so that all of the different use cases that you want to try to do and that you want to try to achieve are already solved and answered, and there is an open community around it. Databases with some of the best communities are MySQL, Postgres, and MongoDB. Unless you have an extremely specific application, do not choose a NoSQL DBMS. This particular point is a little opinionated and a personal judgment. However, it is something that would be echoed by most experienced developers. If you're choosing a NoSQL DBMS, make sure that the use case is extremely well defined, because as a developer, there's going to be a lot of extra work that you will have to do if you go for a NoSQL system. Which also is closely related to the point that do not design the application to be Google scaled from day one unless the application is working in a very specific domain that has to process data at the scale of a few terabytes right from day one. Unless your application is processing a few terabytes of data right from day one, do not even think about any fancy database and just go with something that is popular and that has a huge community around it. My personal recommendation would be to use Postgres, since it is one of the most featureful and stable databases in the world. There are several examples of people running the Postgres database for months and even years without any amount of downtime. Postgres has a very rich community and a very rich ecosystem of extensions that allows it to handle several NoSQL use cases like scale out. For example, Cloudflare uses a Postgres extension called Citus, which allows it to handle hundreds of terabytes of data. And Cloudflare uses that system to perform analytics. Key takeaways are that NoSQL systems and SQL systems are not competing systems, and you should not be looking at them as A versus B. They're usually complementary systems that you are going to use in your application for achieving different objectives. SQL is a very important language to know from a skill set and a career point of view because it is a stepping stone to more specialized use cases for NoSQL systems or SQL systems. The tech ecosystem regarding databases is in a fair amount of flux, so factor in community and maturity when you are choosing a system, and that is in fact the most important point here. Do not trust any random information that you find on the internet about any particular DBMS, or do not trust random benchmarks without understanding how those benchmarks have been achieved, or unless those benchmarks have been vetted by experts. Apply the information that you've learned, that you find in the community, that you find online about DBMSs, and apply that information for your use case only if it is actually appropriate.